Okay, dear colleagues, I'd like to represent you the approach introduced within the research work conducted in cooperation with our US colleagues, comprehensive stratified approach to energy resilience solutions taxonomy, Ukraine scenario. As a precondition, this work has been substantiated our previous steps and actually is aimed at finding out the perspective for the directions of for the research it can be seen appropriately place ourselves among the diverse alternative solutions. Um, Let me go ahead. The content is as follows: introduction, motivation, and so forth. And with respect to the introduction, the core idea the paper is focused on is the grounding on the necessity to shift from the somehow common concept of sustainability to more prominent and comparably knowable novice concept of resilience. And it can be also stated that typical perception of sustainability is aligned in accordance with the safety development goals. And by addressing the energy scenario, the safety development goal 7 can be mentioned. By the way, here's in the upper part of this slide, we can see the interpretation of our within our Ukraine strategy aimed between 2015-2030 interpretation of SDG 7. And here below, you can see also the interpretation provided by the Department of Economic and Social Affairs of the United Nations, more in detail and with a focus on sustainability in particular. Ensure access to affordable, reliable, sustainable, and modern energy for all. Here is what we have typically. And the substantiation for actually the necessity to shift, to move forward, the comparatively novel concept of resilience is here. We can see the high impact, low probability events took place in Ukraine in particular. For instance, the December 2015 can be remembered when about 225,000 of energy consumers faced energy outages. And also yet another representation of such high impact, low probability events is actually the events that prompted by the full-scale invasion of Ukraine. About 40% of power generation have been destroyed by the November of 2022 by physical missile attacks. So here comes the motivation and state of the art. With focus on heat events, energy infrastructures are increasingly vulnerable to disruption due to geopolitical events, natural disasters, and cyber threats, and so forth. That's why the resilience concept is required to be taken into consideration and to be used. So the objective of research is to develop a comprehensive stratified approach to energy resilience solutions taxonomy with an intention to both appropriately withstand the existing solutions and discover the promising direction for further research work. And the comprehensiveness has been delivered through covering the conceptual dimensions addressing the following aspects: intrinsic principle, hierarchical plane, perception of energy infrastructure, and the cyber physical system. Those are the aspects the solutions are considered by applying the proposed approach. Moving forward, here is a conceptual model proposed and placed inside the proposed approach. And the comprehensiveness is delivered by distinguishing between three defining dimensions. The first one, by the analogy of the design patterns taking place in programming, the similar approach has been taken here. With respect to patterns, there are structural um, and so forth patterns, and here we mapped a similar approach, architectural solutions and the ones aimed at policy strategies. This first dimension, the idea here is to catch the intrinsic principle of particular resilience-centric solution. The following dimension address the stratification. Three stratas have been distinguished, starting from the regional level and up to the international level. And here the aggregation has been used too. And with respect to the third dimension, the energy infrastructure has been approached as the cyber-physical system to more appropriately address actually the threat. We do believe that such differentiation is mandatory to adequately withstand particular solutions with the rest. And the main results. Dimension 1. Here, the upper graphical representation is a conceptual model inside the proposed approach. Dimension 1 emphasizes the inner principle inside certain particular resilience-centric solution. Dimension 2 address the stratification aspects, and dimension 3 makes it possible to perceive such an energy infrastructure as the cyber-physical system. And with respect to the approach, this graphical supporting representation is expected to be mapped onto the conceptual model. And the approach is about moving straight forward from the left to the right, from the first dimension to the third one. And each particular solution under consideration is traversed through these dimensions. And the results are depicted in this case study. What about the case study? The Scopus database has been used. The period of search is between 2019-2024, and the keywords for search are energy resilience and Ukraine. And this table actually depicts the dimensions, the first, second, and the third one, and the key components of the dimensions: AS, architecture solution; P/S, strategy policy; and the second one, IES, NES, RES, international energy solution, national level energy solution, and regional level energy solution. And with respect to the dimension 3, either cyber or physical plane is depicted with a C and P letters, plus actually when the solution satisfies certain component, plus minus when there is no clear differentiation provided in certain publication, and minus when this component hasn't been covered in publication. The first part of table, the second one, and what are the findings of our case study? So the significant accent of comparatively modern alternative solutions are on inspiring, are represented in the form of strategies, either in the form of policies. But the architectural-centric solutions lacking the attention of researchers. And here can be mentioned, for instance, among a few these architecture-centric solutions, the paper of Sergei Evgenievich Sauch. And with respect to the dimension 3, many of the alternative solutions addressing the resilience don't provide the differentiation between physical and cyber planes, which also sophisticates the process of taxonomy. Thus, it has been found out that to appropriately withstand our findings with the existing one, to actually look forward at the forthcoming scientific novelties, it can be see a perspective way to approach the regional level energy infrastructures and apply our solution in the form of the architecture-centric one. In the form of architecture-centric one. Here it is, and with respect to the acknowledgement, we would like to thank Dr. Andrew Reen from the DoD Smart Department of the US Army Engineering Research and Development Center. Thank you for your attention.
Thank you for your interesting presentation. Do you have any questions to Vadim? No. So, thank you.
Thank you.